Yes, let's start this. So, hi there, everyone. Tonight, we are going to talk about why we built Joyride and, of course, tell you what it is and what you can do with it. I'm going to show some examples, and then Michiel is going to tell us a bit about what makes Joyride even possible. And then we will look at some more examples. We will continue the demo. But before we do that, we would like your input and your questions. So we will squeeze a Q&A in there and then continue with the demo. And you can also ask more questions during the second part of the demo, because that will be more freewheeling form. I know Michiel is looking forward to more programming VS Code with all of you. So, aren't you, Michiel? Yeah.
Yeah.
So
I already have a REPL into your VS Code from the Netherlands. So
yeah, that's cool. You will have a new REPL to check into in a jiffy. All right. So why did we build Joyride? I mean, Joyride is an extension for Visual Studio Code, which is the most successful of the modern editors, at least in terms of uptake. It has 24 million monthly users on average, and it is growing at an undisclosed pace. Among Clojurians, the VS Code has about 20% of the users, according to the Clojure survey, latest one. On the marketplace, you will find 41,600 extensions, and that is also growing. And I think it's worth thinking a bit about why there are so many extensions on VS Code. And I think I have some of the answers. So one reason, I think, is the VS Code extension API, which is carefully designed and well documented and plain joy to use. By design, it is far less permitting than the extension models of, say, Emacs or Atom. This makes for a quite consistent user interface without the need for a review process. And without this review process, you still have very fast access to the marketplace. So you can start with nothing, and 5 minutes later, you can have published an extension on the marketplace. Of course, this less permitting thing is also limiting. So we extension developers often have to scrap some of our plans because the API just won't allow us to realize them. And this is especially true for extensions trying to support interactive programming, which Calva is suffering from. And I know the extension for Julia is also suffering from this. This is, of course, a very hard balance for the VS Code team to strike. I think they're doing a great job here. So it's 10 out of 10 would try again from me when it comes to that. I think also that another reason for this extension success is the extension development community, which is a super friendly and super helpful place. You Clojurians would feel at home there, I promise you. But this 41,600 extensions is super impressive. I mean, there are often many extensions covering the same use case. I say that for big use cases, that is a good thing. I mean, one user's idea of how something should be solved is very different from some others, so that's really good. For small use cases, though, it can be a different story. And it also seems like the smaller the use case, the more extensions you find. And many of these extensions do not really add enough competition to warrant the cognitive load that they bring with them, at least in my opinion. Which one of all these word counters should I use? And from the descriptions, this can be quite hard to tell. I spent all too much time searching for installing, testing, and uninstalling extensions. if VS Code would let me hack a script that counted words, that could actually take less time, and I would end up with something that's tailored to me. So to be clear, I really love this. There is an extension for that situation. That's lovely. But there are 20 extensions for that. Can sometimes be a bit frustrating. And I think user space hackability can help here. Via settings, VS Code is very configurable. And you can also call any of its commands, including those provided by extensions, from keyboard shortcuts, and you can provide arguments to these keyboard shortcuts. So it's a very flexible system there. Though used like this, they are truly commands, statements with no way to deal with the return values. So this scheme is not Turing complete. To extend VS Code with code, you have to write an extension. And you need to find ways to distribute it if the marketplace doesn't fit. So this is where Joyride comes in. This is the why Joyride. Joyride enables VS Code to be scriptable in user space. So one way to use Joyride is to pop open a prompt. So Joy code, and then enter some code in there. Actually, I should show the Joyride output here first. Joy code. And we can do some calculation here, and you see the result down there. And this code has full access to the VS Code extension API. So if I do the shortcut here, and so this particular code is also opening up a prompt, and then we are using that prompt, the input from that prompt, to show a message down here. And this message box has 2 buttons, and then we show another message that uses the answer we gave. So we could do this because Joyride itself is an extension, and it offers its access to the VS Code API to the user. And this API includes all the commands that are available from VS Code and from extensions. Unlike with keyboard shortcuts, though, you now have access to the return values of these commands. And together with the rest of the API, this means that you can do almost anything with Joyride as you can do with an extension. You can automate some workflow, populate the status bar with information buttons, provide a web view of any interactivity, provide menus, open some file editor, edit the text in there. You can create a slide manager to control your presentations. You can automate some UI tweak that VS Code lacks settings for. You can recreate some retro game, and yeah, so on and so forth. Why not use Joyride as your advent of code environment this year? So let's have a look at the Joyride API here. So these libraries I have here. So the first library there gives you access to VS Code, its API, and the commands. And we also have a syntax here for reaching the API of extensions, of other extensions. And the Joyride namespace gives you some small utilities. You have Clojure Core there, from Misa to managing promises, and the whole world of NPM at your fingertips. And Joyride has this concept of user and workspace scripts. And so these are in the class path. These directories, the user's home directory lives some scripts, and in the workspace directory lives some scripts. And we have commands for listing the user script here. So these, if I would enter here, I would run them. I won't do that now. And but you can also open a user script. These can be a bit unreachable, I would say, if you can open them if you like. And also Joyride will look in these directories at startup, which happens when a new VS Code window is opened. And if it finds an activation script there, it will run them. So it's a bit like init EL for Emacs, I think. Joyride has 4 commands, and these are available for the user and also for other extensions. And so we can run code, as we have shown here, and we have this evaluate selection. So we don't need to copy and paste to the prompt. We can join cell. And this code opens the box. Yeah, and again, I should show the output here. Now I use the keyboard shortcut here, Control-Option-J, Enter. And we have the prompt there, hello world. And we see the result down here. Yeah, so since Joyride has access to all extension commands, it also has access to its own commands. And this can be quite useful. But we'll look at that later. Let's first start with this, a simple example here, or 2 actually. So in this example, we also show an information message with this calculation and a button here. And if that button is used, we execute a command to use the inbuilt browser to show this web page. Let me, and now I run this selection, Control-Option-J, Enter. And this pops open, and this button here, you can press it. And here you can read about why we get that crazy result from the calculation. Yeah, and in here we use the regular promise chain, right? But you can also use Promisa to handle the promises. And here we have, we first take up the workspace root, and then we join that with a path of a file we have in the workspace. These 2 are actually synchronous, but this one, open text document, it resolves to the document. And then we open that document, and then we wait a bit, and then we scroll to the top of that open document. Let's see if that happens now. We're at the button, and now we're at the top of this file. So there's one more thing that we haven't talked about yet, but that we have been using here, a really big thing. That is, of course, the REPL. So Joyride brings interactive programming to VS Code users in user space. But the way we're using it now here, it is a bit clunky, right? So for that, Joyride packs an NREPL server. And it has API to start this NREPL server. And there is another extension that has implemented this API to start the REPL. And that is, of course, Calva, which I, of course, have installed. So it has a command, start Joy. I like that name. And if we do that, the REPL connects here, and we now have a more convenient way to interact with the Joyride REPL. So I can load this file, and we can start inspect and modify VS Code in this more convenient way. So here we have an example here in Zen mode, which I'm using now. It usually hides the status bar. Oh, I haven't started that one, Michiel. Well, oh, yeah, that's another thing here. I started this REPL on port 000, or on the interface 000, which Michael now has used. So he's also connected to my REPL. Where were I? Yes. So we have this status bar here that's usually hidden, but I have configured things to not hide it. So this configuration is false here. And you can inspect some more. So VS Code has settings for showing and hiding line numbers, but it only does it on all editors at the same time. And sometimes you want it in one editor and not in another. So for that, you can use this part of the API actually. So if we inspect it, we see that this property here is 0, which means no line numbers. But then we can toggle it like this if we evaluate this. So we have the line numbers here. I'll toggle it back. So some people don't like to have the line numbers in this output window, for instance. So then you do that. I have line numbers here, but not there. That's one thing you can do. And you can explicitly print to the Joyride output panel. So like that. So I was thinking we could create a status bar item because I like that. And for that, we can use this API here, create status bar item, and we will align it in this right group here. And we will have a high number here to have it far to the left in this group. So if we add it and then show it, we will not see anything here because we don't have a text on it. So if we add the text here. So now we have the status bar item there. And we can hide it again and show it again. And so this thing here, I don't know if you see it, but it's actually a button here, and it has a tooltip. So we can do that with our one as well. So we can add a tooltip to our, so now it has a tooltip. We can add a command to it as well. And for this, you set this property of the item, and at least you need to have a command. And here we are actually using the Joyride run code command. And this is an argument, so it will actually run this code. So let's add that. And now this is a button, and that button should also open this simple browser with this address here. So if we click it, we have the simple browser open there. Now, if we're done with this item, we can dispose it. But wow, what happened now is that we don't have access to it. So now we can show it. We have disposed it. So if we want to play more with this, we need to create a new one. So I'll do that. Of course, we hide it here, so we need to show it again. So now it's back here. I can use it still. Cool, because I want to paint it. We can paint it in gold color, say. So we set the color on it. So now it's pretty. And then we can play a bit with these colors because these colors support alpha. So I made a small function here that oscillates the color, the alpha of the color between 0 and 255. Using cosine here, could not resolve symbol alpha. Or maybe I forgot to evaluate that one. Yeah, so now we have that function. We can test it here. So it's F6, F9, FB, FD, FF. And now we should go down again. And it does. So, and we have a new alpha value there. And then we can define a function here to set this nudge color on the item. And now we can actually nudge the item here. I hope you see it. Not if you do work dude. Cool. Yeah. And then we could, in the interest of time, I won't right now, but you could bind this to a keyboard shortcut and run Joyride code and with these argument, which we would call this function then. And we can be bold and bind this to the space key because VS Code has very precise targeting of of a binding using contexts and this when language you have here. So here, for instance, you have the backspace key that Calva edit uses, and it has like it's only actually is active in certain situation. That's very useful and something you can do. But maybe we don't want to nudge this via a keyboard shortcut because it doesn't really make sense. But we could run this on an interval, of course. And I often lose these references in the REPL. So I have an atom here where I swap it onto it instead here. So now it's flashing this button in a very pretty way there. But maybe we don't want it to go fully black there. So it could be that we want to change that to go from 100 to 255 instead. And then we can update this function, and now it will. So this is interactive programming, right? And something for us to use. I think actually it's time for us to listen to Michiel talk a bit. So I want to show you one more thing. We said that we can create web views. So we have created an example here for opening a web view, and in this web view, it's using Skittle, and it can there is a Clojure script and reagent inside there. So we have it in the workspace, I think. So as a workspace script, the web view example here. So if I run that one, it will open this here. And then if we click it, we have, that's pretty cool. And I guess that is what Michiel is going to talk about as well. So
all right,
let's go over. Take it away, Michiel.
Yeah, thanks. So I'll talk a little bit about the implementation of how Joyride is made. So Joyride as a project, it's a normal Clojure script project which is compiled to with Shadow.cls to a VS Code extension. But what it includes is the small Clojure interpreter, which is a Clojure interpreter which can run in Clojure or in Clojure script. And it's also used in Babeshka for the fast starting Clojure scripting environment, because it can be compiled with GraalVM to a binary, but it can also be used in Clojure script, and it can be advanced compiled together with other libraries into an advanced compiled optimized bundle. Yeah, maybe the next slide.
Maybe.
Yeah. So what you can see here, if you have Psi as a dependency, you can go into a REPL in the Clojure REPL and require Psi.core and then evaluate a string +1 to 3. And you can do exactly the same thing in Clojure script. So you see a node REPL on the bottom. It's exactly the same interface. So the interpreter has access, normally by default, access to Clojure core and Clojure set, Clojure Eden, and all of the pure-ish things. It does not include functions like slurp, etc., because those give access to the file system. And by default, Psi is like you should be able to use it as a sandboxed environment. So all the things you evaluate in there should not touch your computer and cannot erase your hard disk, let's say. So you have to be explicit what you want to enable, but it also has options for giving you access to everything, let's say. But you have to configure it. Next slide. So there are a couple of projects which use Psi as a Clojure script environment. One is NBB. I've given a presentation about that here before at the London Clojurians earlier this year. And Joyride is actually very similar in setup, because VS Code is also a Node.js environment, Electron. And so a lot of things that a lot of experience that I learned in NBB was transferable to Joyride. So Peter mentioned that before this presentation started, that we were able to bootstrap Joyride in basically 2 days before we had the first working version, and that was actually because of the things that were already figured out in NBB. So there is also CIDER, which is an environment to directly write Clojure script in browser tags, which Peter already showed earlier. And there is a website called Forever Clojure, which runs for Clojure exercises in the browser using Sci. And it's used in Clerk for visualizations. There is a website called maria.cloud, which is currently using self-hosted, but it's migrating to Sci to do some, you can have a smaller bundle and have more configuration options, let's say, what you want to do in the evaluation. Next slide. So about how would you configure Sci if you want to use it? If you want to create an environment like Joyride, so we use Sci.core, and let's say we have a function x which increments a number, and you want to expose this function to your environment. So what you can do is you make a hash map with a symbol my function, and then you expose my function as the corresponding value, and then you define the Sci options, and it has an option called namespaces where you provide all the namespaces that you want to expose. And when you do that, you can require that namespace by the name how you exposed it in the string, evaluate a string, and then you can execute that function. So this is the most basic setup. I'm skipping over one detail here. Is normally you would create like a Sci var for the function, but I didn't show that here for simplicity. But if you want to be able to redefine my function, you would create another indirection here. So if you want to do what Peter just showed, re-evaluate functions in REPL, you would create a Sci var, which also has Sci also gives you functions for that to do that. It even provides you functions to copy entire namespaces, and then it makes all those vars for you. The next slide. So there is a project called Sci.configs, which is a collection of ready-to-be-used Sci configurations, so that you don't have to reinvent the configuration for every library that you want to use. And one library that I've been using a lot in several projects, NBB, CIDER, and Joyride, is Promessa, which is a library to deal with promises using Clojure core macros. So it has, for example, a delay macro, which, well, you say delay 1,000 and then a value. So it returns a promise that after 1,000 milliseconds resolves to a certain value. So if we want to use that in Sci, what we can do, we can just reuse this configuration from this project. So then we say we initialize a context with those namespaces from Sci.configs, and then we so a context is like a mutable environment in which your program can make changes. So every time you evaluate something with that context, the state is remembered inside of that context. That's what we're seeing here. And if we provide that context to eval string star, and together with the string that we want to evaluate, then it just works using these configurations. So inside .configs, there is configuration for a reagent, Promessa, and a bunch more libraries that I use a lot in several projects. Okay, next.
It is that they share this. So when we want a new Promisa stuff in Joyride, we add it to this config, right?
Yeah. And the benefit is that I can also then just upgrade an NVB, and then I also have that new function over there. So if you want to provide an environment with Sai that gives you access to your whole environment, like Joyride does, Joyride gives you access to VS Code extension and the global environment, and we don't care. We want to give the user all the power, so it's not a sandbox anymore. But then you can configure it like this. So you say, okay, Sai init, we create a context with classes, and the JS symbol, which represents the global JavaScript environment, and we just pass JS global this to it. And then there is, in ClojureScript, there is one special global symbol called math, which is just JS math. And then you say allow all, which means if you do interop on one of these things, you can also do interop on the thing that was the result of the evaluation of that. So normally Sai only allows you to do interop of what you specify here and not on transitive results of that. But you can turn that off with allow all. And then there is a function called enable unrestricted access, which allows you to alter Clojure core vars if you want to, and also using set in ClojureScript without surrounding it by binding, because normally that's not allowed in Clojure, but in ClojureScript it's just a mutation in place, let's say, similar to alter var root in Clojure. And lastly, Sai also doesn't let you print anything by default. So if you want to allow printing in ClojureScript, you can set the print fun and print air fun to the host's print fun and print air fun. So this is basically what you need to do if you want to create a JavaScript environment, a ClojureScript environment that allows you to do everything. So if you have configured it like this, you can do print math sin 1337, and then it prints a number and it returns nil. So, okay, next.
Yeah, I just have a question. Sorry. How is this configured in Joyride with this allow all thing?
Yeah, it is the same.
It is the same. Yeah.
Yeah.
Thank you.
So how do we load workspace and user scripts in Joyride? So as Peter already showed, we have a way to specify scripts in a .joyride scripts folder in your workspace, and also globally in the user directory. So the next slide will explain or show a little bit of code. So if you execute require Clojure docs, which is a string in our workspace, as docs, so then Joyride searches in these directories for the right namespace name. And so this is a function that we have, source script by ns, and then it finds the file, and this is part of a bigger function in the Sai configuration, and that function is called load fun, which is the way you can specify where to fetch sources from that Sai should evaluate. And there is this is a synchronous version, load fun, which is used in Joyride, but there is now also an asynchronous version of this, which lets you do well, an asynchronous lookup of sources, and we might use that in the future in Joyride as well, but it's not used today. So the next slide. And so the case you saw in the previous slide was in the load function was the symbol case on the top. So if the library name is a symbol, we assume that it's a ClojureScript library, and then we look up the source by the namespace name. But if it's a string, then it's either a node built-in library or an NPM library or an extension. So if the name is VS Code, that's a special case. What we do is we insert a class. So in the first slides, we saw that you can provide a list of classes to CI that the user has access to, but you can also do that after the fact, given the context. So you say add class, you pass it the context, and then you provide the name of the class and then the value. So we treat just a library, we treat as a class, basically you can do interop on. And if you use an alias, we also register that alias and as an import. So, and handle true just says, okay, we're done here. We did everything ourselves. CI should not do anything with the alias anymore, because normally when you when you load a Clojure script namespace, CI handles the alias stuff for you. You just have to provide the source. But here we do everything ourselves, basically. And so the second case is the extension case. I'll just skip over that. And then the last case is actually the case where we load an NPM library. So maybe the next slide we'll get into more detail on that. So if we want to load an NPM library in Joyride, what you have to do in your .joyride folder, you can do npm install a library that you like to use, and then it creates a node modules folder. And so this require star function here, it looks up it creates a node require object which looks from relative to the script that you executed it from. And if you're in a REPL or you don't have you're not in a script, then it just makes up a name which is in the current directory, and then node will start looking in the current directory in your node modules folder, and if it's not there, it takes the parent and so on.
I actually tried to put it in my root folder.
Yeah,
to have global
work,
access.
right?
Yeah, it worked. But
yeah,
I stopped you doing it. But anyway, I tried it.
Yeah. But that's how Node works.
Yeah.
So we resolve the library, which gives you the full path of the. So if you require, let's say, I install the library called Axios, which is an HTTP client, and so the resolved value here is like node modules /Axios /index.js or something, and that is what we then execute with JS require, which is just a global node JS require, and then node handles all the rest. So using this function, we can require this JavaScript in a synchronous way, because Node still supports that. Everything is moving to ECMAScript 6 now, but which is asynchronous. But this is like the older Node.js way of doing things, and Electron actually only supports this way of doing things. So this is why we can still do this. So we require this library, and then we add the library as a class, and we handle the alias, and that's like the same as we did with VS Code. Okay, next.
Yeah, I can just tell people here that when I asked Michiel if we could support NPM, then he said, no, we don't have it. And I think it was 20 minutes later, something like that, they had a PR on Joyride. We can pull, and then I had it. So it was, yeah, that was mind-blowing.
Yeah, and so I think I installed, for this example, I installed Moment.js and Axios. So in that here you can see that we can require it in the REPL and do interop on it. And so yeah, that's so under the hood side, the way we configured this, it is as if you said, okay, import this this class, which is actually a library, and it has this name, which is this alias. So that's just how it's implemented behind the scenes. So yeah, that's why we can do npm libraries. Is there another slide? I forgot.
Let's look.
Oh yeah, so there's one more about the extension API, and Peter knows a lot more about this than I do. But extensions can expose certain functions that you can use in other extensions. So that's the way how extensions can talk to each other. And Calva actually exposes some functions. I don't know what they're doing. Maybe you can explain that. But
Yeah.
but what we implemented this syntax to be able to import also functions from other extensions. That's basically what's happening here.
Yeah. So there's a special thing there with a $V0 there. So you reach down one level into this. Maybe you normally don't do that, but what Calva exposes that this API is an object or a map, if you like, which has a key V0. Because we're a bit on the defense here. It's very, we want to be able to change this API. Or rather add V1 later and not change this one. So the REPL namespace there, or I don't know, that module, it lets another extension use Java Calva's REPL connection and evaluate code on it and those stuff. And the ranges one is reaches into Calva's functionality when it comes to figuring out Clojure code ranges. So the range for the current form, the range for the top level form and stuff like that. So it's very handy when working with Clojure code. We can show an example of this because Sean Corfield has written an example for
Okay,
doing Clojure docs lookups using this.
Yeah. Is there another slide or?
Let's look.
Oh yeah,
there was one more.
So one more. Okay. So nREPL. Okay, we have Peter already showed we have nREPL, and it's fully implemented in ClojureScript. So there's not a JVM starting behind the scenes, which caused some trouble with some existing. Well, in NBB, it caused some friction with other editors, but because Calva is the main Clojure environment in VS Code, I would say, we were able to make this a very smooth environment between Calva and Joyride. The code is almost identical to what is in NBB. So the nREPL server is running in Node.js, and yeah. That's it.
Yeah, it's super great. I love this. Let's see. No, that was the last slide.
Yeah, cool.
Cool. Then we said we wanted to have. I need to move you away here. Yeah, we had those examples. Yeah. Okay, so we have more examples. Here we mentioned NPM. I have one example with parse HTML, and we have the web view if someone want to look at the code for it. We haven't looked at activation scripts. And we have this script here. I call it showtime. We have this slider, the slide show thing. We have the Clojure docs example. I have this script here for resetting the presentation before. For this, I have everything is set up for doing this presentation. And I have another example with this typist thing that I mentioned that I used Joyride to prototype stuff for an extension. And yeah, so we can look at any one of these and start hacking. Anyone wants to look at something in particular? We have something more in this one, I think. Yeah, here we are using Calva API. We can show that one just quickly, I guess. So we require that one. And then we can look at the API here. So we're going to use this editor replace API, which takes a VS Code text editor and a range and the new text and replace it. And we're also going to use here the ranges module and pick the current top level form to replace. And these ranges here have they have this API. I don't know if you can read that stuff, but anyway, so if we look at that here, we pick out the top level form here from Calva. We take the first from the current top level form, because ranges current top level form delivers back the range and the text. So if you want the text, you can use that. So that's a tuple. So we only use the first thing there, the range. And then we call on Calva the editor replace API, give it the active text editor and this top level form range and the new text. And then we print in the output here that we have printed, and if something goes wrong, we catch it. So if we run this, what will happen? If I evaluate the top level form here.
Well, it will be replaced.
Except the bug. What did it say?
Did you evaluate the require already?
Did I? I don't know what happened, but anyway, exactly what you said. So that's one thing you can do. I will undo that. So it's very good for working with Clojure code if you need to do stuff that Calva doesn't do. So we have been able to point people to Joyride for a lot of Calva feature requests.
What's an example of what do people typically do?
So one example.
Because I also see an example or a question in the chat which might be solved with this is ignoring the current form.
Yeah, ignore current form. Actually, I think, let's see. I think we have had that example, actually, that particular example, and wasn't. So that's a good. I think maybe I've lost it for now, but that's one thing you can do. And there is an example in the Joyride repository for it. So you can find it. You can find it there. Ignoring the current form. So that's a very frequent request. And for me, I just say what I do is that I just go out of here, ignore it, and then I go no. Yeah, then I've lost the key binding, but then I go back to where I were. So for me, it's just like another short corner. So I can just run a few keyboard shortcuts and then I do it. So I haven't, but this Joyride script exists in the examples, so you can do it. NPM, we want to look at that one. So this is the post-HTML parser from NPM, and then I have NPM install it as Michiel.
So can you
mentioned.
maybe show in the terminal where you should install it for the people watching?
Yeah, so I have installed this one in the Joyride.
Right, the package.json is inside the Joyride folder, right?
Yeah, so that's where I have put it. then it's available for all the workspace scripts here.
Right.
Well, these are workspace scripts in this workspace. So yeah, so I did require that one, right? And then
Yep.
if we define this, and then we can run it, and we need to Ctrl+2 show output window here, and here you have the code. But the first thing here was recalling the parser here with it. So if you would, okay.
Okay. Did you?
Yeah, let's do.
Did you evaluate the require already?
Let's do it like this. So now HTML has this value, right? Now I can. It should be able to. No, we need to call it as well. No, it should be able to. So this is what you get from the parser. And then we do JS, CJS, keyboard dice keystrat, and then do this post walk. And I do know you did a version that didn't use post walk for it, but it's nice to know that we have post walk there and Clojure zip, and a lot of libraries out there use these as their only dependencies. And even if Joyride doesn't include that library, you can just put that into here, that code, and use a library. So I've used parts of the Hickory library this way because it only depends on Clojure zip, I think. Yeah. Yeah. So that was the examples in this script. So, what do you want to?
What do we do next?
Why don't you show us the timer that you mentioned before? It's a simple example.
Yeah. So this is this timer here, right? So it's I can run it as a workspace script. That's the interface I've done to it. So it is this thing here. So if I just run it and nothing happens here, I need to stop it first and then run it. That will remove it. And if I run it again, it recreates it, and then I can start it. So we can open the workspace script show time here.
Yeah, there is a question by Luke.
Yep.
Where do additional dependencies for Joyride scripts live? So we don't really have that. So if you have dependencies, then for now you should copy those scripts to your projects. So we don't have like support for libraries from Clojures or whatever. Maybe we can introduce that at some point, but right now we don't have that.
No, but you have npm on that answer, which is very rich.
Yeah, and you can even distribute your Joyride scripts on npm, I guess, and then install them. We don't support loading them from node modules yet, but we could.
That's cool. Yeah. So I can show you this script then.
Luke says, I wanted to test out ignore form, but I don't have z joylib on my class path.
Okay. What you will need is the user activate script from the examples as well. And then you need, if you have that one, you need to unignore a part of it, I think, to get it.
It's best to try this example from the Joyride repo because that is a complete setup. And yeah.
We can look at that as well together.
Yeah.
So for this script here, what I have is a state here with items and timers by default. And again, this is my safety hatch here because if I lose this items and timers, then I screw up my environment here. And we have some commands here, and the commands needs to be strings. So what I do to get them readable is that I still a quoted version of the script. And then I have a version for zero padding here. I could have used moment, but I wrote my own stuff here. And let's see here. Yeah, we have evaluate this file. We have a function for updating the item. We pick the item from the state, and we set started at to no, not that. We check the delta from started at there, and we create this full-time label, and then we only pick. So this one will show only minutes and seconds, while there are only minutes and seconds, and then it will start to show hours as well, and even days. So that's what this thing does here. And then we swap this full-time label into the state. And then here we set the item command. And again, it is this object here. So we run Joyride code with these arguments. So that is the command from that command map you saw up there. And we create the started at and the tooltip created from that as well here. And we set that on the item here when we do that. Here's how we stop the timer. So there's a lot of swapping on this state object going on. We disuse the current timer, and we pop the last thing on the timers list, and we set the command to restart, and then we clear this interval. And when we start it, what do we do here? Yeah, so this is how I create the timer and then swap it onto into the timers list in one go. And then we associate this timer and started at, and then we set the command to stop. And here we can remove the item and initialize when this is run as a script. These are some things that we could point at. The Joyride has an invoked script thing you can call, so you know which script is invoked when you invoke it from this this way. The run workspace script or run user script commands. They will have this set. So when that is equal to the current file, then it is run as a script. So then we do this, but I can run this in the REPL without load everything in the REPL without actually running the script. So this is something you probably will have at the end of many of your files. And yeah, so here we have this. I check this thing, right? If it has a timer, then it's running. Then running this script is safe. It won't kill the timer. But if we don't have a timer, then we dispose of this item. So that's if we run update items here. This is the result here. And if we try to, we can remove the item here, of course, if we want, right? And and we would need to recreate it by calling init here. So
Very
let's
cool.
here again. I don't know if you can follow it, but you just ask questions so we can dig into this one. I know Michiel had an idea that we could try to turn this into a Pomodoro. So that's so you would have something like a way to add a label, a thing you're doing, I guess,
Yeah.
and would have a fixed time, like
20 minutes.
10 minutes or something like that. Yeah.
10,
Yeah. And then it would count down maybe, but it can count up. It doesn't really matter, right?
Yeah.
So yeah, so that's actually all there is to this, and that's what I meant when I said that if instead of testing all the timers that are on the marketplace, because there are a lot. Let's see. I need to exit Zen mode maybe to see if I just put timer here. Yeah. So it's yeah, it's really hard to find anything, and I've tried a lot of them, and they really didn't cut it. So then I just wrote my thing, and this one works exactly as I want. I think that's a really cool example. You want to look at the slide, next slide thing?
Yeah.
Yes, there is a question from Joshua. He's asking regarding Clojure dependencies. Is anything preventing a Joyride script from connecting to Calva REPL and uploading project dependency or installing new Clojure libs? Because this seems like a security nightmare.
Yeah. So you can basically do anything you want in Joyride because it's your scripts. So in Emacs, you can also delete your whole hard disk if you want, right?
I can do that with Joyride as well.
And with Joyride, it's the same. And because you can connect to the Calva REPL, you can do anything you would do as a user in the Calva REPL. So there is no restrictions there. But regarding updating dependencies from within the REPL, this actually requires some extra tooling. Yeah. So you cannot do this from the REPL without restarting the REPL without some additional tools. Yeah.
Great.
So this is the script I'm using for controlling my slides. This is all there is to it. So you don't need to. It's Clojure, right? You don't need to write much code to do useful stuff. And I had an idea that we could try to, because what I sometimes miss when I present is to know which next slide is coming. I was thinking I could have like a previous button here and the next button here that could maybe show the next slide, the name of the next slide, or have it on the tooltip. So that's one thing as well. And one thing also that we're using the REPL and a script like this to controlling my slides is that I could create a mobile app that connects to my REPL and use that to control my slides, right? Because I would just like evaluate stuff on the REPL from my phone. Or I could ask Bork to what I did for him, change his slide. He could change my slides because he's connected to this REPL. So I think it's pretty.
Yeah.
Oh,
you can see the pop-up.
Yeah. So if you try to, I think you need to call. You need to call next here. If you call.
What's the name of the
next slide?
Okay, so next slide. Let's say I'm typing next slide / next exclamation mark.
Exactly.
And now I'm pressing enter.
Oop.
So now it's going to the next slide. So I'm doing this from the REPL on my own computer. And so Peter opened up his network port so I could connect to it via Tailscale. And but normally by default, nREPL doesn't start on port 000. So we configured that for today, so we could show this. So I'm doing the next slide now again. There is no next slide.
No, I think that's all my slides actually.
Oh, and then
but you can do
next,
if you
next
you say false.
Oh, false.
Next false, I think it is. Yeah.
Oh yeah, that's the previous.
Of course, it's next false. Yeah.
Okay, cool. Yeah, that's funny. Yeah.
Yeah. So in
now
Joyride,
I'm formatting your hard disk, but no.
Joyride has one setting here actually. So it by default it is using this port.
Cool.
Where were we? We were in here.
It's actually pretty fast that when I hit this and it happens at your side.
Yeah.
So
yes, it's instant, I guess, almost, right?
Yeah. So I can imagine if you make a phone app, it will be even much faster. So it's
So while we're grabbing for things to hack on, I can show you.
Then we should use Clojure Dart to make a mobile app to connect to this REPL.
Yeah, please do. That sounds cool. I want to show you an activation script. So I have a user activate script here. And so it has a bit of a special setup. Maybe not this one. Let me show you the workspace activate script instead. So this one. So VS Code has this concept of disposables. So it's things that you can call dispose on. And a lot of things are like watchers and these items and stuff like that are disposables. So to facilitate hot reloading of this script here, we have all these disposables in this atom here, and then we have a function to clear the dispose. We will call dispose on all of them, and we will then swap on an empty vector here, and then we can push disposables in our script onto this thing, so that we can keep track on what we have created.
What is an example of disposable?
So one example of a disposable is this on did text open document event,
kind of
right?
A handler.
Event handler. That's one example. So if we now would we need to run. We can't just load this in the REPL. Yeah, we can actually call main here. I need maybe to load this. Call main. And now I think that if we open, let's run this workspace activate script then. Because now we should have registered this on did open text document handler.
Prints. Where does it print?
I should be printing. Evaluate that.
Yeah.
Okay, I don't know. Let's maybe if we try to. No, I don't want to do that actually, but we can do it for now.
Okay. Do we have to open a new REPL now?
So it actually should say, wait, it has run this activate script here. And it should actually, because when I have this, that's why it's disabled by default here, because it's very annoying with print. Okay, let's see. No, actually, I used to have it as a show information message. That's what's going on here. Let's start the REPL again. Here, so and we have the output window here. Actually, it's printing it here. That's
here,
what's going on. So
Okay.
now when we go between, we see it here.
Right.
But now if we want to push something else on it in our main function here, we can do so. That was a user activate, I said workspace activate. We can do so because what this will do is first clear the disposal and then push new ones on it. So that's how we hot reload an activation script and can work with the
right. So this allows you to try out different handlers without having the previous ones, which are maybe contains mistakes, right?
Exactly.
Yeah.
So there is a special thing with the activation scripts because they often do stuff like this. But when you develop them, you actually need to be able to just work here with impunity. So that's why we have this setup. So this is I think this is the example you get when you install. We can try that. Because if we remove this activation script here, and then we open the run workspace script here, it offers us to create a new one. We'll download this from the repository, and now we have it here. Actually, this one does have it available, enabled by default. Did you follow what I did there? With removing this one and reinstalling it? So if you just cleanly install Joyride, you won't have this workspace activate script. That's the thing. So then you will have that option in this menu to install it to bootstrap yourself.
And so the activation script, if it runs as an activation script on startup, is invoked script then false?
No, it's true.
It's true because you didn't invoke it yourself, but it was invoked by. So that's
it's invoked here.
Right. So this counts as an invocation of the script. Yeah,
it does.
Yeah. Right. Yeah.
But if I load it in the REPL here, I don't want to invoke it or run
exactly.
It.
Yeah. Any more questions from audience?
Maybe you can show us as last example the web view.
Oh,
yeah, the web view. So we can run it again first here, the web view. So that's this one, right? And then we have it here. So it's this code. And this HTML code. So I think this is better if Michiel describes what's going on here, I guess.
Okay, so this is just an HTML page which loads CIDER directly from NPM. So JS deliver lets you load libraries directly from NPM. And so there is a CIDER.js file, which is the main interpreter SCI. And then there is also CIDER.reagent, which is like a plugin for CIDER, an optional thing that you can also include in your script tags. And now you can write a reagent app directly in a script tag using Clojure script. And what we have here is, well, that's actually an example that you made.
Actually, I just built on your example. So
okay. And
I just added this actually.
So you added the animation, right?
The animation and the logo, yeah.
Yeah. So this is just a React component which shows the Psi logo and rotates it if you click on the button.
Exactly. So we click here.
So this is just a small reagent example, which you can load directly as an HTML page, but it's loaded in a web view in VS Code, and this web view you can create programmatically from Joyride. So, right?
Yes. So this is how it's mounted done in Joyride then. So we're using path here, and but that like comes with the Node, right? So it's,
it's built inside Node to look up the HTML file,
exactly.
and then
we use it to join here at least.
Oh yeah. So okay, path join VS Code root path of the workspace, and then we look into the workspace. We look up this HTML file, and then we say, okay, I want to set, or we create a panel, which is the web view, and then we set the HTML contents into that panel. That's basically it. I don't know if you know this, if you can connect or communicate back.
Yes, you can.
Yeah. Okay. I have never
yes, you
tried
can.
that.
I haven't done it in a while, so I won't do it live here. But but they can send messages between each other. So the Calva output REPL used to be a web view before. Now it's just a regular file, but it used to be a web view. So then we sent messages between the extension and the web view, and the web view could also post messages, and we can pick them up, so they can speak to each other.
And are there any extensions which use this web view for anything fancy, like visualizing?
Portal? Like Portal?
Portal, yeah, okay, Portal, of course, yeah. And so
there are a lot of extensions that use this for fancy stuff, really fancy stuff.
Right. Yeah. So you can do this in Joyride without building an extension, which is the exciting part, right?
Yeah, it's really cool. I don't know why we lose the state here when we go, but we can probably figure that out. It's
can you go to the HTML? And does it have def once in the state? Maybe you can try that.
Yeah.
Def once, and then save.
So and then. This is with the def ones. And if we do that and go like that, we still lose it.
Still lose it. Yeah, I don't know how this works.
I'm convinced we can figure it out, but
can you do the counter? Can you start at like a different number to see if it picks that up?
Here.
Yeah. Yeah, okay, that works.
So it is a new version here, but this one will start at 0 and this one will start at 31.
Oh, okay. That's weird.
Yeah, it is a bit weird. Well, I think we can figure it out, but not now, maybe. But anyway, it's I found it very. I don't know if I can reproduce it for you now, but if I had this to 100%, then here, and then I click this a few times, then it just locked. But maybe I can't do it right now. But there is something with the Chrome layout engine that has problems with 100% width, and then this. I also tried with something like 80 view width there, and web view. and it started to behave really weirdly, like growing and stuff like that. So it is just something I observed when I did this. Nothing to do with Joyride or Skittle. It was just the layout engine has problems with this kind of.
So Lee Reed, who is in the chat, says the Psy logo is beautiful, but actually he designed this logo. So thank you, thank you again, Lee.
It is beautiful.
It is a beautiful logo. So thank you, Lee.
So, but then we have the designer here, because I wondered about that. Is it supposed to have a white background like the Clojure logo when it's on black?
You should ask Lee about that. I don't know.
Yeah, I thought we could.
Oh, he says beats me.
Yeah, because I think. Okay, I haven't activated. Next slide. Because this one looks like that. It has like a. I think this is beautiful. So I was just. I didn't know when I did this, so it was.
As long as we have parents, we're happy.
Yeah. Do we have any more suggestions in here?
I think we've seen a lot already.
Yeah. We haven't done a keyboard shortcut, of course, but. Okay.
Maybe we can, as a last thing to show. So how can you configure, if I make this script, how can I bind it to a key? Yeah, so we could look at I think it's here. We have the Clojure docs. That's nice. A script here. So if we open that one. So this is like an adaptation of what Sean Corfield has. He has his configuration on GitHub for people to use. But this one uses Calva and then the REPL of Calva to evaluate the symbol and resolve it to figure out where we should go on Clojure doc. And then we build the Clojure doc URL here, and we have this function here that looks up this form. So if we would be on this, let's say print line, for instance, and we would run this script, it opens that in Clojure docs. And if we look at the key binding for this, is on this one, open default keyboard shortcuts. It's default keyboard shortcuts. That was default keyboard, so that's the wrong one. This one was what I was looking for. Okay. So if we look here, I have a lot of this Joyride run code, and this is what happens when we press left in the browser. So we should check that we have input focus here. And how does it check when you have next slide : active? Good question. So we can look then in the next slide script here. So this key only executes when you have this condition. And how does it? So we toggle activate here. We do execute command set context and this. Okay. So this is just a string. I use this colon as a convention for myself. Cool. And then we toggle it. Okay, but nice. if we would I think this would be the equivalent of like a minor mode or something in Emacs.
Okay. Huh? So if we would remove this input focus check here, and now I have to use we need to activate it as well. Yeah. So that it wasn't active. Now it was. Now it's active. And if we press left now in an editor, I mean, it does that. So that's what that input focus thing does. Where did the keyboard shortcuts go? So we really need to check that. It took me a while to figure it out because I tried with this editor focus, blah, blah, blah.
But what is actually input focus?
That's a good question. So so this is the language you have. For a long while, they didn't have OR, which was very annoying. But now they have OR, at least. And you can do regular expression matches and stuff like that there as well. And you can check settings with this one as well, which is great. But they have all these available contexts here. So input focus, this one, for any text input area has focus.
But when you're giving a presentation, you're not in an input field, right?
Exactly.
Oh, so it's not input focus, right?
Exactly. It's not input focus.
So you're not in a code editor or something.
Exactly.
Yeah.
But when I have this not editor text focus, things seem to work. But then when I was in the Joyride prompt here, for instance, and started so the input focus is the important thing.
Right.
So this is good to know. But let's look at the
Clojure docs.
Clojure docs. Here, let's here we have it. So what I do there is that I run Joyride code with this argument. This is just calling that function, right? And I have it on Control-Alt-C-D. So if we go here and
so Control-Alt-C is for Clojure and then D is for docs or something?
Yeah, Control-C is the Calva key as we usually think of it. But we have this print line with swap here, Control-C-D. And I can look it up in Clojure docs. It's very good in Joyride because the Joyride NREPL doesn't implement info NREPL op. So we don't get hovers and stuff like that.
We could do that.
Yeah, that would be. But now
it does
with this
for. Okay. Yeah, we can take that offline.
Yeah, Calva assumes info to do that, so we don't get the hovers and stuff like that here. So actually, we don't get the Clojure LSP's help either.
So
I don't know why.
The Babashka NREPL does support like LDoc something.
Yeah.
And CIDER uses this to provide these hover things like the argument list. I think LDoc. It's more or less the same as the info operation.
Yeah, I could implement that in Calva.
Yeah.
Or we could just call it info. Yeah. Sorry.
Maybe we already have this. I'm not sure. We could. So
anyway, so this is, I think, a very this example of Joyride in the real world was, I mean, it's this is what one of our colleagues did when he got Joyride.
And how do you fetch or no, you fabricate the URL and then you open a web view with this URL, right?
Yeah, so I use this range's current form on Calva.
Right.
To get and here I don't mind about the range. I only need the text here.
Yeah.
And then we create this Clojure docs URL from it, which resolve it in the REPL. I don't know why we couldn't go there, but here it is. And so we actually resolve it against the REPL connection. So this doesn't work statically.
Yeah, but it falls back on the static.
It falls back
option.
on, this is probably Clojure core and this symbol.
Yeah. Cool. Well,
Hmm?
I think we've seen a lot of examples, and I hope people are inspired. And
I hope so too. I can drop Emacs now and hack VS Code.
Everybody's probably hacking already, so. And yeah.
Very cool.
Okay.